Hello, my students. Today we will talk about the second part of organic chemistry, topic 11. We will talk about naming and drawing the displayed formula for different functional groups, alkanes, alkenes, and carboxylic acids and esters. Also, we will draw some products of the chemical reactions, especially for alkanes reactions and alkenes reaction. Mainly, we will talk about the rules of naming different functional groups and homologous series of organic substances. Okay. The first thing here, we have the points from our syllabus. We will name and draw the displayed formula of methane and ethane from alkanes, ethene, ethanol from the alcohols, ethene from the alkenes, ethanoic acid, and the products of some chemical reactions. That's done in section 11.4 and 11.7 for the organic substances. You will name and draw the structural formula of different alkanes, alkenes, alcohols, and carboxylic acid. Also, we will talk about at the end of our lecture about esters and how they are formed from alcohols and carboxylic acid reactions in the condensation reaction. First of all, we shall know the first rule for naming organic molecules. It depends on the number of carbon atoms. This is number of carbon atoms. And as you know, for naming, you have prefixes and suffixes. So the prefix which is used for the naming, depending on the carbon atom, are first, if we have one carbon atom, so we will use the prefix meth. If we have two carbon atoms, we use eth. 3 carbons, prop. For 4 carbons, we use the prefix bute. For 5 carbons, we use pent. For 6 carbons, it's hex, and that's what is demanded. 7 carbons, this gives you hept, and 8 carbons, it is used, what is used, oct, and for 9 and 10, we can use oct, dec, noon, things. Okay, so like that we can use more than 8. So 9, it is dec, and 10 we use noon. So these prefixes comes from how they count. Before they count like methagon, ethagon, propagon, butagon, pentagon, hexagon, heptagon, octagon, decagon, nonagon, and so on. So instead of counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now, for naming, to start in the naming, we can use these prefixes. Okay. We can use these prefixes, okay, to do more than one example. Like, for example, let us start with naming of alkanes. Okay, like, for example, this color. Let us start with alkanes. The alkanes formula you know. Let me remind you, the alkane. For example, the first alkane is CH4. Its displayed formula is known like that. C, 1, 2, 3, and 4 hydrogens attached with 1 carbon by 4 covalent bonds. Now, for the second alkene, we can draw 1, 2, and then complete them to hydrogens like that. That's what is known ethane. So we used the prefix eth, and because it's alkane, the suffix which is used ane. So it depends on the suffix, and the prefix. The suffix will give you the number, the prefix will give you the number of carbon atoms, and the suffix will identify the type of the homologous series. For example, if he asks me to draw the third member of alkane, which is known as a propane, it's like that. You can connect 3 carbon atoms with each other, then complete this structure by doing covalent bond with hydrogens. So that's what is named a propane. Next, homologous series. We are talking about the alkenes. We can draw more than one alkene. You know, alkenes are CnH2n plus 2, CnH2n, sorry, the 2n, that's the general formula. So we can apply this general formula to write different molecular formula and draw different structural or displayed formula. Like, for example, C2H4, that's the simplest alkene, which is named what? It's named ethene. So it is eth, the prefix, and we add the suffix from the name of the homologous series. That's where we have the 2 parts of naming. I told you before, to add or to create the next alkene, you can add CH2 for between the homologs of the homologous series, and to the next one is C3H6. So that's what is known as a propane. Now, to draw this structure, as I told you, we can draw 3 carbon atoms, but here we have what? We have double bond, so we shall omit the structure like that, and for the structure we have carbon 2 and 3. You can select the position of the double bond like that. So here we have alkene, where the carbon can share 4 electrons also. But now, look, this is 1, 2, 3, 4. 1, 2, 3, 4. You can see it is not like alkane. It will do 4 sharing by the double bond. So always you shall count the number of covalent bonds around the carbon atom. They shall be 4 all the time. So this is what propene. Now, we have something else about the alkenes. For example, in drawing different isomers of the alkene of 5 carbon atoms, like this, for example, you can change the position of the double bond. Here you can put the double bond on the second carbon, and you know all these are hydrogens. This is hydrogen. This is hydrogen also. These are hydrogens. Okay. Now, this is named like that. It can be named pent, because the carbon or the double bond comes on the second carbon. It is pent to ene. The rule says in naming, you shall count from the lowest number, or you shall give the functional group and the locant the lowest number. Because if you count here from right to left, what you can get 1, 2, and 3. But the 3 here is not used because it's higher than 2. So always we select the lowest number for identifying our locant or to identify the position of the functional group, like the double bonds or the alcoholic group. Now, the next point is we can draw a structural isomer for pent to ene, like that. For example, if we draw 1, 2, 3, 4, 5, so like that we select the same number of carbons. We can put the double bond, the carbon double bond on the first carbon. Now count the 4 sharing electrons, 1, 2, 3, 4, 1, 2, 3, 4, this is hydrogen. Now 1, 2, 3, 4, this is saturated carbon. And here we have 1, 2, 3, 4, 1, 2, 3, 4 covalent bonds around each carbon. Now for this, it is the first, and here we have pent 1 ene. Like that, we identified the position. This is the position of the double bond. This one will show the position of the double bond. So this is the location or the locant or the position of carbon-carbon double bond. It starts from carbon number 1, 2, 3, 4, 5. So we shall count 2 in this direction. This is about the alkenes. Now for some alcohols, we can start naming some alcohols structures from 1 to 4 carbons. Let me remind you, within the structure of alcohols are named according to the same rule, according to the number of carbon atoms and according to the functional group. For example, this is COH1. So it will be what? It will be methanol. So that's methanol. Okay, because only we have 1 carbon atom. And for the different structures like that, 1, 2, or you can put the structure. Okay, like that, this is called ethanol, because we have 2 carbon atoms and we use the suffix OL, but the prefix eth according to the presence of 2 carbon atoms. We want to talk about the structural isomers, where they are positional structural isomers for alcohols. We can name these different structures like that. For example, if you have 1, okay, sorry, we have 1, 2, 3, 4, 5. So this is an alcohol with 5 carbon atoms. So its formula is C5H11OF. Okay, now you can select the position of OH group on the first carbon. So you will see that this is the first carbon in the structure, and this is the functional group. Okay, now you can see that the position of the functional group is on the first carbon. So this means that it is 1 all. Okay, so it is 1 all because the position of the functional group comes on the first carbon atom. If we counted from right to left to this direction, so if we counted in this way, in this direction, to have the first carbon there, the second, the third, the fourth, the fifth carbon. Now the name of the structure is pentan 1-ol. I will do it again. So let me write the name in a clear way. Sorry. So it is pentan 1-ol because the position of the double bond, the alcoholic group, comes on the first carbon. Now, the second probable structure for this alcohol, we can change the position of the carbon of the alcoholic group 1, 2, 3, 4, 5. So if you put the alcoholic group on this carbon like that, you will see that okay, the alcohol or the term ol comes on the second carbon. So you will see this idea. Now the second carbon and the functional group comes on the second carbon. So the name of this alcohol, it's number 2 from this side. So it is 2-ol and its name pentan 2-ol. So it's pentanol or pentan 2-ol. So like that you identify the position of the alcoholic group on the second carbon. What else? We have carboxylic acids. Okay, for carboxylic acids, you know the general formula of the carboxylic acid. The carboxylic acid is like that. First, you have CnH2n plus 1 COOH. Okay? Now, to apply this formula, we have different carboxylic acids. For example, C2H5COOH. This means that we have 3 carbon atoms in the structure of carboxylic acid. You will see something like that, 1, 2, and 3. The third one where we have the functional group. So it's drawn like that. That's the displayed formula. In the displayed formula, you shall show all bonds, okay? In the displayed formula, you shall write all bonds shall be clear, and focus that we have carbon double bond with oxygen, okay? And here we shall continue the structure with hydrogens. Remember that in the external exam, it is not allowed to write the formula without hydrogens. It's very important to know where are the hydrogen atoms. Okay, for the carboxylic group, you know that it's terminal one, so always it is on the it's on the side, or it's in the terminal side. It is not in the middle like the other functional groups. So always when we name, we count from the carboxyl group or functional group, then we are going to this side. So we start from the side of the functional group to the other side. Okay? That's one example about the carboxylic acid. We can draw more carboxylic acids like that. For example, if we started within the functional group like that, we can add many carbons like what you want. Let us try to name this structure. And this structure contains 1, 2, 3, 4, 5. Okay, and here we have 7 carbons. Okay, we start counting again from this one, where the functional group, it will take the first, that's the second, the third, the fourth, the fifth, the sixth, the seventh one. So this one is named what? It's named heptanoic acid. Okay, let us return back to the other acids. This one is named as a propanoic. It's a propanoic acid because we have 3 carbons. Now, after that, you can do like an assessment to test your knowledge. So I will give you a question and try to find the answer. Okay. Now, the next functional group that we shall know how to name its structure, it comes from the reaction of alcohol plus carboxylic acid. So that's ester. It's a compound comes from alcohol and carboxylic acid. Look, let me tell you how they are formed. They are formed like that. If you have, for example, 1, 2, and we have alcoholic group, that's what's named as ethanol. Okay, and if this is reacted with COOH, and we have 2 hydrogens and 3 carbons like that, So this is named propanoic acid. Now, what's removed from the structures is the hydrogen ion from alcohol and the OH group from the carboxylic acid. Okay? Now, by this, water molecule was condensed, and this will give you C, C, and C. Here we have O, then C double bond O with C and C, C. Now, to name the esters, you shall start with the alcoholic part and then with the carboxylic acid part. So the name of this ester is like that. The name of that ester is like that. We start from the name of, okay, we start from the name of the carboxylic acid like this, okay. Now the carboxylic acid is a propanoic acid and the alcohol is the ethanol, so this is ethyl propanoate. You will see that's the carboxylic part, and this is the alcoholic part. Next time we will do more examples after discussing each functional group by itself. Okay, thank you for good listening. We will do more practice about organic chemistry in the coming videos. Thank you, bye-bye.